You know, when you sent over those excerpts from The Sixth Element, I gotta say, at first, I was like, carbon, okay, sure. But this book, wow, it really, it goes deep, like
Yeah.
way deeper than I expected. We're not just talking about life on Earth here.
Right.
We're talking about the entire universe, the whole history of carbon.
It's true. Carbon's story is surprisingly grand. I mean,
Yeah.
it's the story of how we get from a universe born with practically nothing but hydrogen and helium to, well,
To us.
to us and diamonds. Don't forget the diamonds.
Oh, right. And speaking of diamonds, that part about the super deep diamonds, like the Cullinan diamond blew me away. It's not just that it's this massive sparkly thing, it's that it formed way down in Earth's mantle, like a place we can't even get to.
It's like the Earth is hiding this treasure trove of information down there.
Right.
These super deep diamonds are like time capsules with little bits of minerals trapped inside. They give us clues about what the Earth's mantle was made of billions of years in the past.
That's incredible. But, okay, let's rewind to the very beginning.
Right.
Back when the universe was just a baby. The book mentions the Big Bang didn't just poof carbon into existence.
Right.
So how did we go from a universe of simple elements to, well, everything?
Okay, so picture this. It's billions of years ago, and inside a star, 3 helium atoms are having a very important meeting.
Okay.
They're moving incredibly fast, colliding with insane force.
Yeah.
And when the conditions are just right, bam, they fuse together, forming a single carbon atom.
Oh.
That's the amazing triple alpha process.
Okay, that already sounds kind of miraculous to me, but 3 helium to 1 carbon, that seems wildly inefficient.
You're telling me it almost didn't happen at all. In fact, there was a scientist named Fred Hoyle.
Okay.
He looked at all this and he basically said, hold on, if carbon is this unlikely, how are we even here?
Wow.
He predicted that carbon atoms must have this hidden energy level, a sweet spot that makes the triple alpha process just barely probable enough for carbon to actually form in any meaningful amount.
Wait, so he's basically betting on a hunch about the universe based on the fact that we exist. That's some serious confidence.
Yeah, and the best part, he was absolutely right. It's called the Hoyle state.
Wow.
And without it, the universe would be a very boring, carbon-deficient place. No diamonds, no planets, no us.
Wow. Talk about an aha moment.
Right.
But here's something that's been bugging me. If carbon is this abundant element born from stars and all,
Yeah.
why is it relatively rare on Earth? Shouldn't it be everywhere?
Yeah, that's a key point the book makes.
Yeah.
While the universe is practically swimming in carbon, it's kind of like the Earth was playing musical chairs when the solar system was forming.
Okay.
And carbon was a little late to grab a seat.
Huh?
A lot of it ended up farther out in the icy depths, where it was cool enough for carbon compounds to hang out. So how'd it get to Earth? Asteroids and comets? Basically, cosmic delivery trucks brought a lot of it in later on.
So all the carbon we rely on, the stuff in our bodies, our coffee, even the book itself, it's basically stardust from outer space.
Exactly. And not just any stardust, mind you.
Right.
This stuff was forged in the heart of dying stars, flung across the galaxy in spectacular supernova explosions, and eventually some of it ended up here, on this little blue planet, becoming part of us.
Mind blown. Okay, now that we've established that we're basically walking, talking collections of stardust,
Right.
let's get down to why carbon is so special here on Earth. The book keeps mentioning carbon's amazing bonding prowess. But what does that even mean? What makes it such a versatile element?
It all boils down to its electrons.
Okay.
Imagine carbon as this friendly atom with 4 arms outstretched, eager to make connections.
Okay.
Each arm represents an electron that it's willing to share. And unlike some other elements with just 1 or 2 arms, carbon's 4 allow it to form these incredibly strong and stable bonds called covalent bonds. It can link up with up to 4 other atoms at once.
So while other elements are sticking to 1 or 2 dance partners, carbon's out there forming a conga line of atoms.
Exactly. And it's not just about the number of bonds, it's about the type of structures they create.
Okay.
Think of it like this. If other elements are building with just a few Legos,
Yeah.
carbon is like having an unlimited supply in all shapes and sizes. It can form long chains that stretch like highways, intricate rings that interlock like a complex puzzle,
Wow.
and mind-bogglingly complex 3D structures. It's the ultimate molecular architect.
That explains why there are so many different carbon compounds. Caffeine giving us our morning jolt, diamonds sparkling on our fingers, even the intricate molecules that make up our very DNA.
It's incredible, isn't it?
Yeah. Speaking of diamonds, let's dive deeper into those. They're not just a girl's best friend, are they?
Oh, absolutely not.
Yeah.
Diamonds have a story to tell that goes far beyond sparkle and glamour.
So diamonds, they're not just sparkly, they're like time machines or something.
Yeah.
Holding secrets from deep inside the earth. Like every diamond is a tiny vault, right?
That's a great way to put it. Remember we were talking about those super deep diamonds like the Cullinan?
Yeah.
Well, because they formed under such intense pressure.
Right.
They often have these tiny imperfections, little inclusions of other minerals.
Okay.
And those inclusions, they're like messages from the past, telling us what kinds of elements existed in the Earth's mantle billions of years ago.
So by studying these super deep diamonds, scientists can piece together a picture of what our planet was like when it was young, way back before continents drifted or volcanoes erupted the way they do today.
Exactly. It's like finding a diary entry from the Earth's teenage years. It's a level of detail we could never get from just studying rocks on the surface.
That's amazing. It's like the deeper we go with diamonds,
Right.
the further back in time we can see. But the book didn't just stop at diamonds underground, though.
Right.
It took us to a diamond in the sky. How does that even work?
Right. It turns out there's this white dwarf star, billions of years old, that's essentially one giant diamond. We're talking like bigger than Earth. Imagine that light show.
Okay, that definitely wins the prize for most bling in the cosmos. But let's shift gears for a moment.
Okay.
We've been talking about the wonder and sparkle of carbon and all.
Yeah.
But the book also delves into its less glamorous side. Energy, innovation,
Right.
and the big one, climate change.
Yeah, it's true. Carbon is, it's a bit of a double-edged sword.
Right,
On one hand, it's the backbone of modern life.
totally.
It fuels our industries, forms the basis of materials like steel and plastics,
Right,
even the rubber in our tires. It's nearly impossible to imagine life without it.
it's everywhere. But that convenience comes with a pretty hefty price tag, right?
Unfortunately, yes.
Yeah,
The book, it dives into the ethical dilemmas surrounding diamonds,
yeah.
particularly conflict diamonds. These are diamonds mined in war-torn regions,
Right.
used to finance violence and human rights abuses.
It's awful.
It's a dark side to the diamond industry, a stark reminder of the human cost of our fascination with this precious stone.
It's a sobering thought for sure. And then there's the even bigger issue of climate change.
Yeah.
The book mentions how the carbon dioxide we release by burning fossil fuels, it's like throwing a thick blanket over the earth,
Right.
trapping heat and warming the planet.
Yeah, that's the greenhouse effect in a nutshell.
Right.
And it's directly tied to the carbon cycle.
Okay.
What's fascinating is that Earth has its own way of regulating its temperature over, very long periods.
Okay.
This intricate mechanism called the carbonate-silicate cycle. Imagine it like a global thermostat,
Okay.
with carbon dioxide acting as the dial.
Okay. So how does this thermos work?
It's a complex dance between rocks, oceans, and the atmosphere.
Okay.
Basically, carbon dioxide gets pulled out of the atmosphere through processes like rock weathering and the formation of seashells over millions of years. That carbon gets stored away in rocks and sediments, effectively turning the thermostat down.
Okay.
But then, volcanoes erupt,
Right.
releasing some of that carbon back into the atmosphere, and the cycle continues.
It sounds like Earth has its own balancing act going on. So where do we humans fit into all of this?
That's the problem, isn't it?
Yeah.
By burning fossil fuels at such an alarming rate,
Yeah.
we're essentially cranking up the thermostat way faster than the Earth can handle. It's like we're fiddling with this delicate instrument without really understanding the consequences.
Yeah.
And the impacts are already being felt worldwide.
Yeah.
Rising sea levels, extreme weather,
Yeah.
disruptions to ecosystems.
It feels like we're caught in a bind here.
Yeah.
We need carbon for our modern way of life.
Right.
But using it so recklessly is harming the planet.
Right.
How do we find a balance?
That's the million-dollar question.
Yeah.
And it's one that, scientists, policymakers,
Yeah.
innovators, they're all grappling with it right now.
Right.
The choices we make about energy, innovation, our relationship with carbon, it's going to determine the future of our planet.
It's a lot to consider.
It is. But the book, it reminds us that there's more to the carbon story.
Okay.
It's not just about what's happening here on Earth. It's a cosmic story that stretches across the entire universe.
Now my curiosity's piqued again. Tell me more.
Okay, so let's journey beyond our atmosphere.
Okay.
Into the vast spaces between the stars. You might be surprised to find what's lurking out there.
Okay, cosmic carbon. I'm ready to be amazed here. What's out there between the stars?
So imagine a giant cloud, right? But not of water vapor, but of gas and dust. And it's stretching for light years.
Okay.
These are interstellar clouds, and they're sprinkled with carbon.
Okay.
And you might think, space dust, not very exciting, right?
Yeah.
But this is where it gets really cool. This carbon it's forming molecule, the
Right.
building blocks of, well, everything.
So not just simple atoms floating around anymore, but actual molecules. Like what? Give me some examples.
Okay, so we're talking everything from methane,
Okay.
which is, the main ingredient in natural gas here on Earth,
Right.
to carbon monoxide, which is, well,
That's so good for us.
yeah, not so friendly to humans. But it's super important for understanding how stars form.
Okay.
And here's where it gets really weird. There's also PAHs.
PAAs.
Yeah, these complex ring-shaped carbon molecules that we normally associate with things like soot.
Wait, soot? As in the stuff from chimneys and car exhaust? You're telling me that's floating around in space?
It's wilder than it sounds. These PAH are actually really good at absorbing certain wavelengths of light.
Okay.
And astronomers have been finding these weird dips in the light coming from distant stars for over a century.
Wow.
They call them diffuse interstellar bands, or DIBs. So imagine looking through a prism, but some of the colors they're just missing.
That is seriously strange. So are you saying these PAH, these space soot molecules, are they the culprits? Are they behind those missing colors?
That's the billion-dollar question. Astronomers are, they're still trying to piece the puzzle together, but these PAHs, they're a prime suspect. It's like a cosmic game of hide and seek, with carbon, playing a leading role.
I never would have imagined that something as familiar as carbon would be at the heart of such a cosmic mystery.
Right.
It's amazing. But the book went even further, talking about carbon in distant galaxies.
Yeah.
What's its role in these massive structures?
Think of galaxies as like these giant cities of stars,
Okay.
each with its own carbon fingerprints.
Okay.
By studying the light from these galaxies,
Yeah.
astronomers can trace the history of carbon across billions of years. And let me tell you, it's been through a lot.
Yeah.
It's been incorporated into new stars, flung out into interstellar space by supernova explosions,
Yeah.
even swallowed up by black holes.
Black holes. You mean like the things that even light can't escape from? Carbon can't possibly survive that, can it?
Well, not in its usual form, no.
Right.
Black holes are, they're the ultimate recyclers, right?
Yeah.
Pulling in matter and energy. And,
Yeah.
and who knows what else happens beyond the event horizon. It's a bit of a cosmic mystery.
Mm.
But the point is, carbon's journey through the universe, it's full of these twists and turns, from the hearts of dying stars to the edges of black holes. It's a wild ride.
So we've gone from carbon's explosive birth in stars to its role in these incredible cosmic processes.
Yeah.
What does it all mean? Why should we care about carbon's journey across the universe?
It's about more than just facts and figures, isn't it?
Right.
It's about perspective. The very same carbon atoms that make up our bodies,
Right.
that sparkle in a diamond that we're, struggling to manage here on Earth.
Yeah.
Those atoms were forged in the hearts of stars billions of years ago. They were part of something much grander, much older than we can even fathom.
It's almost humbling in a way to
Right.
realize that we're connected to these vast cosmic events.
Yeah.
We are stardust, literally.
Exactly. And that stardust, it tells a story of creation, transformation, and even a little bit of destruction. It reminds us that the universe is constantly evolving.
Right.
And we're a part of that story, whether we realize it or not.
Wow. I have to say, when I first, sent in those excerpts from The Sixth Element,
Yeah.
I never imagined we'd go on such an incredible journey. From the heart of an atom to the edge of a black hole. It's really been a wild ride.
It's amazing how one element can connect us to such profound concepts, isn't it?
It really is.
It's a testament to the power of curiosity and the endless wonders that science reveals.
Absolutely. This deep dive has definitely changed the way I look at the world, and even at myself.
Yeah.
To think that the carbon in my hand might have once been part of a distant star. It's mind-blowing.
And that's the beauty of it all, isn't it? There's always more to discover, more to learn, more connections to be made.
I couldn't agree more. Well, on that note, I think it's time for us to wrap up this incredible deep dive into the world of carbon.
Yeah.
A huge thank you to you, our expert, for sharing your knowledge and insights.
Oh, of course. It was my pleasure.
And to you, our listener, thank you for joining us on this journey. Until next time, keep exploring the universe and all its wonders.